Hello, am I audible? Hello, am I audible and is my screen visible? Hello, can anyone let me know if I am audible and if my screen is visible? Hello, can anyone let me know in the chat if I am audible? Okay, thank you. So good evening everyone. Welcome to this NPTEL live session for the NPTEL course Introduction to Machine Learning. This is my sixth live session. My name is Ayan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So in this live session we will discuss some practice problems on week 6 topics, which was decision trees. So we will solve some practice problems on decision trees, and if you have any other queries or doubts, please feel free to ask me. So we will start solving the practice problems. This is the first question. Which of the following properties are characteristics of a decision tree? So there may be multiple correct answers here. So three options are there: low bias, high variance, lack of smoothness of prediction surfaces. So which of these following properties are characteristics of decision trees? Multiple options may be correct here. You can write your answers in the chat. I have not received any answer in the chat yet. So has anyone found out the answers? So I got one answer in the chat. Raghav is saying all, A, B, C. Any other answers? Anyone else? So the correct answers here are A, B, C. So Raghav has said the correct answer in the chat. All three options are correct here. So the first two options, low bias and high variance, this is because decision trees have a known issue with overfitting. So it is very easy for decision trees to overfit on the training data. So and we know that for overfitting, these are the two main problems. Bias will be low and variance will be high. So this happens because of the overfitting nature of the decision trees, because the models are so complex in case of decision trees that it overfits very easily. So low bias and high variance, these two are correct options. And the third option is lack of smoothness of prediction surfaces, and this is also easily understandable. So if this is the overall feature space. So we divide this the feature space like this kind of diagram has been shown in the video lectures also, that if these are the two features x1 and x2, so we divide this feature space like this rectangular blocks or regions. So and these are the decision surfaces or decision boundaries. So the prediction surface is not smooth at all. So once you cross this decision boundary, you go to a new region and value drastically changes, even for regression tree and also for decision tree, classification tree. So the lack of smoothness of prediction surfaces, this is also a correct answer. So A, B, C, all three options are correct here. So now we move on to question 2. So a diagram is given. So this is a small decision tree with only one root and only two leaves. So you have to find out the value of the information gain for this decision tree. So there are 30 examples initially, and then we partition the dataset or the examples, and 17 goes to the left subtree and 13 goes to the right subtree. So this is the partition, and the entropy values are also given for the root that contains all the examples, and also for the two partitions. So you have to find out the information gain for this following decision tree. And information gain is basically the entropy of the whole data set minus total entropy of all the partitions combined. So you have to find out entropy of the whole data set and then subtract with the entropy of all the partitions. Pratik Tiwari is saying option C, which is 0.190. Has anyone else computed the answer? I've got one answer in the chat only. So has anyone else computed this? Raghav is saying option A, which is 0.380. Pratik Tiwari is saying option A. So I've got two answers in the chat. Both of the answers are option A. So for this question, you have to find out the information gain. So for information gain, first you need to get the entropy of the whole dataset, which is this root. So the entropy of this of the root is given, which is 0.996. This is the entropy of the complete dataset. So 996 minus, now you have to find out the entropy of so weighted entropy of first partition and weighted entropy of second partition. So out of 30 examples, 17 are going to the left subtree and 13 are going to the right subtree. So these are the weights for these two partitions. So we have to use these weights. 17 by 30 into entropy is given here for this partition, which is 0.787, plus 13 by 30, which is the weight for the right partition, and the entropy of the right partition is given here, which is 0.391. So this is the information gain. So this is the information gain. This is how you have to calculate information gain, and if you calculate this, it would be option A, 0.380. So this is the overall formulation. Is there any questions or doubts regarding this problem? So we can move on to question 3. Hello? Yes.
Because if I see in this entropy after partition and it will be combined with this 1.7.3, it is greater than the previous entropy which is on the right. So
Yes.
how we say about
So yeah, so there are two ways. Either you compute the information gain, so you calculate the information gain for every attribute or feature, and you have to pick the feature with the highest information gain. Or if you compute the entropy or the cross entropy, it is also called in the video lectures, I think it is called cross entropy. So this is the cross entropy. Sorry, this part is the cross entropy, because this 0.996, this is the entropy of the root that would remain constant for each of the partitions that we will make for each of the attributes, right? So if we compute only the cross entropy, this is the cross entropy of all the partitions. Then we have to pick the partition or pick the feature with the least cross entropy. So this is the rule. So Either you can compute information gain, in that case you have to pick the feature with the highest information gain, and if you compute only the cross entropy values, then pick the feature with the least cross entropy value. So does this answer your question? Okay. So now we move on to question 3. Which of the following is true for a decision tree? 4 options are there. Decision tree is an example of linear classifier. Option B is the entropy of a node typically decreases as we go down a decision tree. The entropy of set increases with its purity. And option D is an attribute with lower information gain is preferred to an attribute with higher information gain. So which of these following options is true for decision trees? Raghav is saying option B, which is the entropy of a node typically decreases as we go down a decision tree. Okay. Anyone else? Mr. Pandey is also saying option B. Okay. The correct answer is option B. So first option is decision tree is an example of linear classifier. This is certainly not right. Decision tree can model any kind of data. It's not just linear classifiers. It can create non-linear classifiers or non-linear regressors also. And option B is the entropy of a node typically decreases as we go down a decision tree. So this is correct answer. So as we have seen in the previous question also, that the entropy of the complete data set or the entropy at the root is greater than the combined entropy of all the, or weighted entropy of all the partitions. So this is correct. And option C is the entropy of a set increases with its purity. This is not right. And entropy decreases with its purity. Purity in terms of how many positive and negative classes are there. So if all the elements belong to only one class, then it's completely pure. And if different classes are mixed within that set, then it is impure. So if the set becomes completely pure, so the set contains only one class, in that case entropy would be 0, so it would decrease. And option D is an attribute with lower information gain is preferred to an attribute with higher information gain. This is also not right. We prefer the attribute or feature with higher information gain, and that would be higher. The attribute with the highest information gain will be chosen for the root of the decision tree. So option B is the only correct answer here. Now question 4. Suppose we use the decision tree model for solving a multi-class classification problem. As we continue building the tree with respect to the generalization error of the model, option A says the error due to bias increases, option B says the error due to bias decreases, option C is error due to variance increases, option D is the error due to variance decreases. So what happens once we start building the tree? So as we continue building the tree, what will happen to the bias and the variance of the model or the decision tree? And multiple options may be correct here. So Raghav has written B and C. So B is the error due to bias decreases and C is error due to variance increases. Okay. Any other answers? Pratik Tiwari has also written the same thing, B and C. So the correct answers are B and C. So as we discussed on also in a previous question that overfitting is a problem with decision trees. So it's very easy for the decision trees to overfit the training data, and if it overfits, in that case the bias will decrease. Bias is basically the error, prediction error or estimation error, and it would decrease, but variance would increase. So these are the two correct answers. So as we continue building the decision tree, it is possible that we overfit the data. In this case, model is sufficiently complex, that is the error due to bias would be low. However, due to overfitting, variance starts increasing. Now question 5. When building models using decision trees, we essentially split the entire input space using, there are 4 options: axis parallel hyperrectangles, polynomial curves of different or of order greater than 2, polynomial curves of the same order as the length of the decision tree, and none of the above. So I have got 3 answers in the chat. All 3 are option A.
Excuse me, sir.
Yes.
Sir, actually, I had a doubt regarding the examination.
Exam, I have no information about exams. It would be better if you ask your doubt in the discussion forum. There, the regular TAs and instructors should be able to answer your question, or even NPTEL, the admins can also answer your questions regarding exam.
Okay, sir. Thank you.
correct answer is option A, axis parallel hyperrectangles. So as we have seen that if this is the overall feature space, we divide the feature space like this. So we are using these axis parallel hyperrectangle. So this is rectangle for 2D, but if we extend it for 3D, 4D, so for more dimensional feature space, in that case it would become hyperrectangles. So option A is the correct answer. Question 6. In building a decision tree model, to control the size of the tree, we need to control the number of regions, or basically the number of leaves. Number of regions is number of leaves. One approach to do this would be to split tree nodes only if the resultant decrease in the sum of squared errors exceeds some threshold. For the described method, which among the following are true? So option A is it would in general help restrict the size of the tree. Option B says it has the potential to affect the performance of the resultant regression or classification model, and the last option is it is computationally infeasible. So the approach is to do this would be to split the tree nodes only if the resultant decrease in the sum of squared errors exceeds some threshold. Then only we split the node, otherwise that is the leaf node. So if we use this method to reduce the number of regions or the number of leaves in the decision tree, so which of the following are true? And multiple options may be correct here. Three answers are already written in the chat. Misty Pandey is saying option A, which is it helps restrict the size of the trees. Raghav is saying all, A, B, C, and Pratik Tiwari is saying A and B. Okay, so I've got three different answers in the chat. Anyone else? So A and B, these are the two correct options here. So A says it would in general help restrict the size of the trees. So this is certainly correct, that we will split the tree only if the resultant decrease in the sum of the squared errors exceeds some threshold. So for many cases the resultant decrease in this squared error would not exceed the threshold. In that case we will not split the node any further. So in that case the number of leaves would decrease, and consequently the number of regions would also decrease. So overall size of the tree would decrease. So that's why option A is certainly correct. Option B says it has the potential to affect the performance of the resultant regression or classification model. So this option is true, because we are not splitting at every node. We will split only if the error exceeds some threshold, but it might happen that some split is not very good, so the resultant decrease is not that much and it does not exceed the threshold, but a subsequent split in that branch only or in that subtree only, that we might get a subsequent good split later on, but if we don't split at the node because it does not exceed the threshold, then we will not get the good split that we might get later on in that subtree. So this might happen with decision trees. So that's why if we restrict it in this way, it might affect the performance of the resultant tree, and it would decrease the it would increase the estimation error or the classification error. And option C says it is computationally infeasible. It is computationally feasible. We just have to compute the decrease in the squared error at every node. Whenever we try to split, we will compute that, and if it exceeds the threshold, then we will do, otherwise we don't. So it is feasible. So option A and B, these are the two correct answers. So the explanation is also written here, that it is very common for the splits at one level which themselves are not that good, that is they do not decrease the error significantly, to lead to very good splits, but the error is significantly reduced down the line. So this might happen, but if we don't split at that point, then we might not get that good split. Question 7.
Just
Yes.
so if we have threshold with let's say, so does that mean we always use this kind of subsequent trees that are good? I wanted to have a threshold, and in that case, example, I can get the best tree or something.
No, not in all cases. I mean, for certain decision trees or for certain training data, this might be a problem, that performance would decrease because of this threshold. But in some decision trees, this might not be a case. So it completely depends on the decision tree and the problem that you are solving with the decision tree. So it might not happen all the time. This is used, this technique is used, but this has this drawback that performance might be affected, but not in all cases, obviously. Now question 7. Consider a dataset with only one attribute, which is a categorical attribute, and suppose there are q unordered values in that attribute. So that attribute is categorical, so there are q number of possible values for that attribute, unordered. How many possible combinations are required, are needed to find the best split point for building the decision tree classifier? There is only one attribute and there are q values possible for that attribute, and how many possible ways are there to find the best split point for the decision tree classifier with that feature? And we consider only binary splits, not multi-way splits, because although the attribute has multiple different categorical values, but we are only considering binary splits. So Pratik has already written the answer, option D, which is 2 to the power q minus 1 minus 1. Okay, anyone else? Shankar Lal is also saying option D. Anyone else? Sankalal is saying option C. Okay. Which is 2 to the power q minus 1. So you have to find out how many possible combinations are needed to find the best split point for building the decision tree classifier, and there are q values. So 1, 2, 3 like this to q. These are the possible values of that attribute. So basically you have to split this set into two parts. So this can be done in how many ways? So QC0, which is we are selecting 0 elements, so all the elements are in only one split. QC1, only one element we pick, and all the other q minus 1 elements are in the other split. QC2 like this, QCQ. So this is 2 to the power q. So this sum is already known. It would be 2 to the power q, and out of that we have to remove this one QC0 because this is not splitting at all. All the elements are in only one split and the other split is completely empty. Similarly, this is also the same, and so this QCQ minus 1, which would be here, these two are exactly same. So because in case of QC1 we are picking one element and putting it to one split, and the other q minus 1 are in the second split, and in case of QCQ minus 1 we are selecting q minus 1 elements and putting it to first split, and the second split contains only one, so these two are duplicates. Similarly, QC2 and QCQ minus 2, these two would also be duplicates. So that means you have to remove these two, so it would become 2 to the power q minus 2, and then these duplicates we have to remove, so we just divide it by 2. So for every QCI we will have QCQ minus I. These are same splits, so we have to consider only one, so that's why we can just divide it by 2. So it will become 2 to the power q minus 1 minus 1. So this is how you have to calculate it. So first you have to remove this QC0 and QCQ because these are not splitting at all. This is putting all the elements in only one class, only one split, and then you have to remove these duplicates QCI and QCQ minus I. These splits are exactly same, so we can just divide this whole thing by 2. So the result will be 2 to the power q minus 1 minus 1, which is option D. So option D is the correct answer. So is there any doubts in this question? now question 8. This is basically a neural network. Neural network given below takes two binary valued inputs, x1 and x2, and both the inputs are binary valued inputs, so 0 and 1, these are the two only possible values for both x1 and x2. And the activation function is binary threshold function, which is hx is 1 if x is greater than 0 and 0 otherwise. So here is this hx, and if it is if the x is positive, which is greater than 0, then the output would be 1, otherwise the output would be 0. Which of the following logical functions does it compute? And the weights are given here, minus 12 plus 8 plus 8. This is the bias term, plus 1. So OR and NAND, now these are the four options here. So which logical function or logic gate does it compute? I have already got two answers in the chat. Raghav is saying B, Pratik is also saying B. Okay, so B is AND gate. Sankarlal is saying option B. So for this question, you have to simply compute this input output table. So there are only four possible combinations of these inputs, x1 and x2, because both are binary valued inputs. And this, using these weights, so using these weights 12, 8 and 8, this neural network is basically computing 8x1 plus 8x2 minus 12. So if this if this quantity is greater than 0, then output is 1. If this quantity is less than equals to 0, then output is 0. So this is the expression that we have to compute for these four. inputs. So for 0 0 it would be minus 12, so both x1 and x2 would be 0. Then for 0 1, so this is 0 and this is 1. In that case it would be 8 minus 12, which is minus 4. Sorry, so for the first one it was this quantity was minus 12, so minus 12, that means output would be 0. And for the second input, which is 0 and 1, so it is 8 minus 12, which is minus 4, so it's still negative, so output would be 0. And similarly for 1 0, this quantity is still negative, 8 minus 12, which is minus 4, so it's still 0. And then for the final input 1 1, so it is 8 plus 8 minus 12, so it's 4, so it is positive for this 1 1 input. So if this quantity is positive, in that case output would be 1, so 1. So this is the overall input output table that you have to compute. And from this truth table you can say that it is similar to AND gate. So the output is true or 1 only when both the inputs are 1, and in all other cases the output is 0. So this is AND gate, and is the correct answer. So this is how you have to compute. You have to first find out the expression that this neural network is computing, and for this input output table, for every combination of the input values you have to compute this expression, and whether the expression is positive or negative. Based on that the output would be either 1 or 0, and then you have to compare it with all the logic gates, and in this case it is same as AND gate, so AND would be the correct answer. So AND is the correct answer. Question 9. Decision trees can be used for the problems where 4 options are there. The attributes are categorical, the attributes are numeric valued, the attributes are discrete values, and option D is in all of the above. So in which cases or in which problems can we use decision trees? Pratik is saying option D, Sankalal is also saying option D. Okay. Raghav is also saying option D. So all 3 answers in the chat are option D. The correct answer is option D in all the above cases. So first option was that attributes are categorical. So if the attributes are categorical, so the values are unordered for that attribute. So we can simply use the multi-way split at every node, or we can also go for binary splits. So we will split the overall possible values for that attribute into 2 sets. So binary split can also be done, but multi-way split is much better in that case. And the second option is the attributes are numeric value. This is the easiest one. If the attributes are numeric values, that means real numbered attributes, or continuous valued attributes. In that case, we just get a threshold, and all the values lesser than that threshold would be in one split, and all the values greater than the or equal to that threshold would be in the second split. Or multi-way split can also be done. In that case, we have to take more than one threshold for every node or for every split. And the third option is attributes are discrete values. So if the attributes are discrete valued, we can the split like the continuous valued attributes, that we take a threshold, because in case of discrete valued attributes, the ordering might matter. So if the values are ordered, in that case we can pick thresholds. All the values lesser than the thresholds would be in one split, and all the values greater than that threshold would be in another split, or even multi-way or binary split can also be done. So in all three cases we can use decision trees, but the splitting would differ in all the cases. Now question 10. In a binary classification problem, yes.
In decision tree, can you say this thing like decision trees are more performance are more better on the case of classification side that
Yeah, this might be possible, because in case of regression, what we do is that for every region or for every leaf that we get, we just pick the average of all the values in that. In case of regression, we do that. So because of that, the smoothness in the surface is lost. But in case of classifications, that problem is not that much there. So because in regression the output values are continuous valued at outputs, so that's why the completely just by splitting or creating regions, and for each region we are we are getting the average of all the outputs in that region as the output for that region. So because of that, in case of regressions it might not be the best choice, but in case of classification this problem is not there, because we know that there are only several possible output classes are there, so this smoothness problem would not be there that much. Raghav is saying our entropy and cross entropy is same. Yeah, I mean the entropy and cross entropy are used in the same meaning, so these two are same in case of decision tree at least. Entropy is also used, cross entropy term is also used in case of decision trees. Now question 10. In a binary classification problem, out of 30 data points, 12 belong to class 1 and 18 belong to class 2. What is the entropy of the dataset? So it contains 30 examples and 12 belong to class 1 and 18 belong to class 2, and you have to find the entropy of the whole dataset. Sankalal is saying option A. Okay. Anyone else? Has anyone else computed the answer for question 10? So the formula for entropy is minus summation over pi log pi. Base 2 is used generally, and I belongs to set of classes. So for all the classes we have to compute pi log 2 pi and sum it up, and this negative is there in front of it, so that the overall value would come as positive. So this is the formula for entropy. So there are two classes, class 1 and class 2. So P1 is simply a fraction of elements that are the data points that are in class 1. So 12 out of 30 are in class 1, and in P2 there are 18 out of 30, so 18 by 30. So these are the only two things that we need to compute this entropy. So entropy would be minus P1 log base 2 P1 minus P2 log base 2 P2. So you have to compute this thing only, this expression, and P1 P2 values can be computed from the question, and you have to plug in these two values of P1 and P2, and if you compute, the result would be option A, 0.97. So this formula is simply used here. So there are only two classes, so P positive P negative has been used. If there are more than two classes, in that case it would be P1 P2 P3 P4 like this. Question 11, this is the last question. So this data set is given, and this profitable, this is the output class level, which is either yes or no. This is the decision variable or the output variable, and price, maintenance, capacity, airbag, these are the four input features or attributes. So for this data set you have to find out which attribute should be chosen as the root for the decision tree with multi-way splits, because there are the features or attributes are categorical, like this low, medium, high, and also this 2, 4, 5. So more than two values are there for most of the features. So you have to use multi-way splits, not binary splits, using cross entropy impurity measure. So which feature should be selected as the root of the decision tree? So you have to basically compute the cross entropy with respect to each of these four input features: price, maintenance, capacity, airbag, and then you have to select the feature with the least cross entropy as the root of the decision tree. So this question might take some time, so you can take your time and write your answer in the chat. And multi-way split has to be used because there are more than two possible categorical values for price and also for maintenance, capacity. And this calculation will take a lot of time, so I will just show you how to solve such problems. So you have to take every feature of these out of these four and compute the cross entropy with respect to that feature. So first we will pick price. So this is the feature. There are three possible values: low, medium and high. Three possible values. So there will be a three-way split. This is for low, this is for medium, this is for high. So there were total 1 2 3 4 5 6 7 8 9 10 11. So there were total 11 elements, and in the first split for the price value of low there are 4, and out of these 11 there were 1 2 3 4 5 6. So 6 yes and 1 2 3 4 5 no's were there in the original data in the root. And in the low partition or the first partition, how many yes are there you have to check. So we have 1 yes, 2 yes, so 2 yes are there and 2 no are there. So this is the first partition. Similarly for price value of medium, so these are the price value of medium. There is 1 no, 2 no and 2 yes. So 2 yes and 2 no. So this is second partition. And then in the third partition, where price value is high, so 2 yes and 1 no. So 2 yes, 1 no. So this is the overall partition, and for every such partition you have to now calculate cross entropy from these counts: 2 yes, 2 no, 2 yes, 2 no and 2 yes, 1 no. These are the three partitions. So this can be calculated like this. So this first term here, this is the cross entropy with respect to price. So 4 by 11, this is the weight for the first partition low. So this was price, this is for low, this is for medium and this is for high. So 4 out of 10 are going here and 4 out of 10 are here and 3 out of 11 are going in high. So that's why 4 by 11, 4 by 11, 3 by 11, they are the weights for different partitions, and this is the entropy of the low partition. So because there are 2 yes and 2 no, 2 yes, 2 no, so it will be 2 by 4 log base to 2 by 4 minus 2 by 4 log base to 2 by 4. Similarly, this is the cross entropy for the medium partition and this is the cross entropy for the high partition, and you have to multiply these weights with each of these partitions and then add all three entropy values to compute the cross entropy for the complete for this whole attribute. Similarly, you have to do this for maintenance, and there are three possible values for maintenance: low, medium and high. So you have to do this multi-way split again. 3 splits would be done from maintenance, and you have to compute these weights for every partition: 2 by 11, 4 by 11, 5 by 11, then these cross entropy values for each partition. And this is for capacity, this is for airbag. So if you compute cross entropy values for all the attributes, now you have to pick the attribute with the least cross entropy value, so which is the cross entropy value for capacity. So capacity, this is the attribute. So this attribute has the lowest cross entropy and it will also have the highest information gain. So capacity would be chosen as the root of this decision tree. So this is how you have to calculate this the root for a decision tree from a data set. So option C, capacity, is the correct answer. Pratik has written the correct answer, C. Is there any question or doubt here? So these were the problems that I wanted to discuss in this live session. In case of, I couldn't hear.
Linearly separable.
Linearly separable.
Boundary can be drawn, but if it train it with the dysentery, it will have a zigzag. Instead of a line, there will be a zigzag because it is parallel to the features. In previous videos, so in that case, if it is zigzag or a linear line, would that make any change? In case because dysentery is always give a boundary which is parallel to axis. So does that make any difference to performance or because it all dysentery can also classify that linear.
Yeah, so if it creates a zigzag line, that means it is overfitting too much. It is not generalizing well. So it is.
In case like both the two classes are very separate, far away. In that case, if this will be learned, then it will draw a zigzag line that class, right?
It might learn, yes, it might, because decision tree is non-linear in nature, so it might not just create a straight line as logistic regression or SVM might do. It might create a zigzag line. Yeah, that.
Previous solving session mentioned that it will create a zigzag line instead of a straight line. In the case of so I'm just asking, is that differentiate between? The dysentery doesn't stop as classifying that two classes. Does the performance differ in case of
that is what I'm saying, that it might be overfitting the data too much. If it, instead of creating one straight line, if it creates a zigzag, that means it is trying to overfit on the training data too much. So the generalization error or the test error might not be very good for that decision tree, because if the other regression methods are able to generate a simple straight line or a linear decision boundary, it would be better. So it would be able to generalize much better, and the generalization error or the test error would also be low for those regressors. But for decision tree, generalization error would not be very good if it creates zigzag line. No, I mean zigzag line that decision tree is creating is based on the training data only, but a straight line can be found, but it instead of generating that straight line decision tree or linear decision boundary, it is going for the zigzag way. That means it is trying to fit the data too much, which might not be necessary. So in that. It can also create, yeah. I mean, simply one partition is, if simply just consider this, that these are the plus data points, these are the minus or negative data points. So this is the feature space. Only this partition would do the job, isn't it? Oh, in that case it would not be able to do that. If the points are like, so this should be the linear, this is the it would be zigzag, because it would be like this, something like this it would have to create, because it is always axis parallel. The decision tree straight lines that it would create would always be axis parallel. So in that case it would be like this. Yeah, that is what I am saying, that the training error would be low because it is able to classify, obviously, but this is certainly not better than this straight line, isn't it? This zigzag way is not better than this straight line. So the test error would not be very good for the decision tree decision boundary. That would be better for this straight line.
But both performance, if we see it will give 100% accuracy.
I mean that is what I'm saying. On the training data it would, because it is completely trained on the training data, but it is not
Test also, it's a test also classifies.
Yeah, it might happen if the test data are like this here and here, it would perfectly classify. But if the test data is let's say somewhere here, the negative point is here, so because of this zigzag pattern it would classify it as positive, but it might not be actually positive. So the test data it has not seen, so it doesn't know what would come in the test data. Training data it has seen, and based on the training data it has created this zigzag decision boundary. So is there any other questions or doubts? Are there any questions or doubts regarding any of the problems that we solved today? So if there are no other questions or doubts, then thank you everyone for joining. We will end this meeting now, and we will again meet next week for another live session. Thank you everyone.